I will post this on YouTube in case you missed something or you want clarification or you want to show your friends how awesome your math teacher is. Okay, here we go. 1-2B. We're going to do some properties of our real numbers today. Properties of real numbers. And I usually like to tell you how many parts we have. That way you're like, okay, how much more do we have to go? You know, we just have 2 parts today. We're going to first talk about comparing numbers, okay? And we're going to graph numbers on a number line. Compare numbers. All right, so have you gotten the calculator yet? You working your way? Yeah, you got it? Some of you did? Good. Okay, so if you haven't, that's okay. Get it soon, maybe this weekend. You can get out to Target or Staples or Amazon, something. Okay, so we're going to use the greater than or less than symbol to compare a couple of numbers. What happened? You okay?
She said that Staples is cheaper than Amazon.
Oh, is it? Oh, okay.
Oh, I'm passing judgment because
You know, we can look this up and like compare some prices later. I would totally do that. All right, so here we go. We're going to compare the square root of 17 and 3.8. Okay. So we're going to put either a little greater than or less than symbol in between. Do you remember doing this? And there was like a box right here and you had to choose. And yeah, my son does that. It's really fun. So if you have a calculator, that's nice because you can go straight to your calculator. And you don't know how to use this yet, so you need to get used to using it. The buttons are in weird places, okay? If you have an older calculator, you can use that if you want to until we really start to use graphing calculators. So the square root button is in a kind of weird place. I don't know if you see it, but it's blue and it's above the x squared button. It's right there. Do you know how to get to that? Second. So you hit second x squared. That gives you the square root button. And you want to take the square root of 17. Before you press enter, is the square root of 17 going to be more than 4 or less than 4? It's more, right? Because the square root of 16 is 4. Square root of 17. So you don't even really need to do this. But if you want to, you don't really trust yourself. And that's going to be 4.12, whatever. 4.12, and it goes on forever because it's irrational, right? It's gross. All right, so which one's bigger, 4.12 or 3.8? Well, 4.12 is greater, okay? That's all you have to do. Just compare. You just write that symbol down, and you're done. What about comparing negative numbers? So let's compare negative square root of 26 with negative 6.25. Now, on your graphing calculator, on your brand new calculator, there is a negative button. You can't use the minus as a negative. I'll show you. See, the minus button's over here, and the negative button's down here. It's in parentheses. I don't know why they wrote it like that. It's kind of weird. If I write negative 6, it thinks I'm trying to subtract. It's doing answer minus 6, okay? That's a minus button. So if I want negative, I would go negative square root of 26. Is negative 5.09. So I have negative 5.09 about. Is that going to be greater than or less than negative 6.25? It's greater than, yeah. So negatives work the other way, okay? The smaller the number is negative, that's the better one. All right, so that's just comparing. I think you got that pretty good. We're also going to graph these on a number line. I know it's funny because this seems so easy, right? But maybe some of you need a refresher, and that's okay. So let's graph negative 5 halves, the square root of 2, and 2.6 repeating on a number line. It doesn't have to be perfect. Basically, when they want you to do a number line, they're really asking you to figure out what order these things are in. So we draw a number line. Most people like to put what in the middle? 0. We're all so basic. All right, so let's go 1, 2, 3, and you can label your number line. Negative 1, negative 2, negative 3. And then let's go ahead and plot our things. So negative 5 halves. I think I'd rather have that as a decimal. Do you know what that decimal is without using your calculator? Negative 2.5, negative 2.5. So let's go to negative 2.5. There it is, right there. Okay? And then the square root of 2. Square root of 2 is about, what is it, 1.14, 1.41? I get that mixed up. So square root of 2 is 1.41. So I'm going to go to about 1.41, so maybe just right before 1.5, right about there. Doesn't have to be perfect. I'm trying my hardest not to make it too perfect. And then 2.6 repeating, that would be right after 2.5, so somewhere closer to 3 than 2. Okay? And that's how you would just graph on a number line. Pretty basic. All right, so that's the first part. And now let's get to the second part. Yeah?
Would you have to label which ones you
No, you can pretty much see where they're at. Yeah, you'll be fine. All right, so now we're going to go ahead and do our properties. Okay? And there's more memorization coming up. You're going to need to know these properties. Okay? So I'll ask you on the next quiz, which is next Tuesday, I'll ask you, which property is this? And you need to know which property it is, okay? All right, so here we go. We're going to make a little chart. We're going to have our property here. And then our property is going to be good for addition and multiplication. Okay, these properties do not work for subtraction or division. Multiplication. All right, here we go. Property, addition, multiplication. So we have 1, 2, 3, 4, 5, 6 properties. You're welcome. All right, 6 properties. Here we go. The first property is called closure. And you know, closure is not like you break up with someone and you need closure. It's not that kind. Right? Closure property basically says this. If I take a real number, I'm going to call it A, and I add it to another real number. Closure means that this is closed. If I take a real number plus a real number, I am going to get a real number. I'm not going to get an elephant. I'm not going to get a square. I'm not going to get a balloon. Okay? I take 2 plus 3, I get 5. Number plus number equals number. That's what closure is. And that works for multiplication too. You take A times B, you will get a real number. Some kind of a real number. That's very basic, right? You're like, duh. Okay, I know I'm not going to get rainbow if I take 3 plus 2 equals rainbow. Right? All right, so here we go. The next one is commutative. I've gotten some interesting answers for this. People say commutative, like it's interesting. So this is the way you spell it, commutative. Commutative is the property that says, and you've learned these before, but you may not remember them. It says if you take A plus B, it's the same thing as switching them and getting B plus A. 2 plus 3 is 3 plus 2. Now, do you see how that wouldn't work for subtraction? 2 minus 3 is not 3 minus 2. It works for addition, and it works for multiplication. A times B is B times A. So that's called the commutative property. I like to think of it as communication. Communication works both ways. I communicate with you, you communicate with me, and it goes like that. All right, the next one is associative. Never abbreviate associative with 3 letters, okay? Associative. Thank you, I'm here every day. All right, the associative property is like this. You have an association of 2 numbers, let's say A plus B, and they're adding together, and then you add C to the mix. It's the same thing as regrouping. Instead, maybe you might want to do A plus B plus C. Okay? So with associative, groups change. The order didn't change. You see how it's still ABC equals ABC? ABC, ABC. Nothing changed, and the order didn't change, but the groups did, the associations. Like, I don't want to associate with that guy anymore. I'm going to go associate with this one. Okay? And that works for multiplication too. So if you have A times B times C, it's the same thing as A times B times C. And I know you use this. Like, for example, if I tell you to do 2 plus 3 plus 7, okay? Don't a lot of you go 3 plus 7, 10 plus 2, right? You use it. You didn't change any order, but you regrouped it like that because it's easier. You know 3 plus 7 is 10. All right, moving on. Identity. Identity property. So the identity property of addition is if you take any real number and you add it to a special number, you get your identity right back. What is that special number? Zero, yes. These are all kind of duh properties, right? Like, duh. A plus 0 is A, of course. Multiplication. A times what number gives you A right back? 1. A times 1 equals 1. That's called the identity. When you look in the mirror, you see your identity. You see it right back. A is still A when it's added to 0. A is still A when it's multiplied to 1. Okay. One more. Inverse. Well, two more, sorry. Inverse property. Okay. The inverse property is if you take A and you add it to its opposite. A plus negative A. What's that going to give you? 0. Good. 5 plus negative 5. Negative 10 plus positive 10. Okay? Inverse. They also call this the opposite property sometimes. You can write that in parentheses. Okay? Inverse, opposite. All right, and then for the inverse property for multiplication is if you take A and you multiply it by its reciprocal, as long as A is not 0, then you will go ahead and get 1. And this is also called the reciprocal property sometimes. Reciprocal. Okay, and I have one more. I got rid of a few. There's more in your book, but we want you to know, Miss Cowie and I, we want you to know just these properties for the next quiz. And then there's the last one, which is the distributive property. And the distributive property uses both addition and multiplication. So it covers them both. And you know the distributive property. You've done it before. If you have a number on the outside and you're multiplying it times the sum, do you know what you can do with that A? Distribute it, right? So this is equal to AB plus AC. And that's called the distributive property. I'll tell you which ones people miss. People get commutative and associative mixed up all the time. Those are the ones, okay? Identity is pretty basic. And by the way, the book will say the identity property of addition. I don't need all that. Identity property is fine. I can see that it's addition, okay? All right, so what are we going to do these? We're going to do some examples with these. So we are on number 4. A few more, and then I'll give you a chance to start your homework too. All right, so the question is, and I have 4 of these to go, which property is being illustrated here? Which property? Okay, so here we go. If I take negative 2/3 and I multiply it by negative 3/2, I will get 1. Which property says that a number times its reciprocal equals 1? Do you see it? Yes, there it is. It's the inverse property. Inverse property. So anything times its reciprocal equals 1. That is the inverse property. You can write inverse property of multiplication. You don't need to write all that. Inverse property is fine. Okay? All right, let's try another one. Letter B. Let's do, here's one. 3 times 4 times 10. And maybe instead you don't want to do 3 times 4 times 10. You'd rather do 3 times 4 times 10. That might be an easier way to solve it, or maybe you like to do 3 times 4 times 10. But there's a property that says that those are equal to each other. And what property would that be? Associative. Yes, associative. Now, here's the thing. Some people will think, oh, okay, associative is whenever I see parentheses, and commutative is when you don't see parentheses. Well, then they'll really try to mess with you. So they'll do this. They'll go 3 times 4 times 10 equals 4 times 3 times 10. And so some people will be like, okay, there's parentheses in this problem. It must be the associative property. This is not associative, right? Did the associations change? No, 10's left out. 10's been left out the whole time. What happened was 3 times 4 and 4 times 3 got switched. And which property is that? Commutative. Okay? So don't just look commutative. I can never spell that. Commutative. There we go. So don't just look at, oh, there's parentheses, associative. Make sure you look at what the problem's doing. Okay, and then one more. Last one. Let's do 3 times g plus h plus 2g. Okay, pretty soon we're going to start to simplify those things and group and get our like terms together. I think we do that tomorrow. So the thing that you would need to do is you need to take that 3 and multiply it in to get 3g plus 3h plus 2g. And we're going to use this property in order to simplify. So what property is being used to get from here to here? Distributive. Perfect. Okay. Like I said, there's not a lot of work to be shown on these problems. You just look at them, you write down the property that it is, and you're ready to go.
Sorry, what does it say after the 2?
Over here? Oh, that's a G. Sorry, 2G. Yeah, it's the same 2G right here. That was right there. So the only thing that changed was that 3 distributed there.